So we are going to start looking at what we call oblique triangles. So by definition, an oblique triangle is a triangle that does not have a 90-degree angle. So far we've been looking at 90-degree angle triangles, but oblique triangles don't have that situation. The naming conventions are exactly the same. If you have A, B, and C, and you can consider those your side lengths in lowercase letters, then capital A, B, and C are the angles associated with them, and they're always opposite. So side A faces angle A, side B faces angle B, and side C faces angle C. So let's just draw a random triangle and refresh ourselves on the naming. So we have an oblique triangle, which does not have a 90-degree angle. So if we call this A, B, and C, that means opposite to angle C is side little c. Opposite to angle A is side little a, and opposite to angle B is side B. So this is the same regardless of whether you're dealing with a right angle triangle, whether you're dealing with an oblique triangle. So we know that if we do have a triangle that has a 90-degree angle in it, or a right angle in it, we can use two things. We can use Pythagorean Theorem, or we can use the primary trig ratios, which is basically the SOHCAHTOA. But both of those require having a hypotenuse, right? Pythagorean Theorem, we need to know what the hypotenuse is. In SOHCAHTOA, you'll notice the hypotenuse is always showing up in terms of the formulas. But in an oblique triangle, we don't have a hypotenuse. So we cannot use Pythagorean Theorem or the primary trig ratios of SOHCAHTOA. We need to use actually other formulas associated with it. So we still are going to use sine and cosine, but we're going to use them a different way. So we have other formulas. And the equations that we're actually going to use for oblique triangles are called the law of sines and the law of cosines. So just as before, you do not need to memorize these formulas. Let's go to our resource sheet and see sort of what the formulas that are provided on your resource sheet. So if you scroll down to the section related to triangles, you do have Pythagorean Theorem, a squared plus b squared equals c squared. You do have your primary trig ratios, SOHCAHTOA, and that's only for 90-degree angles. But if you have oblique triangles, like the following, then we're going to be looking at no 90-degree angles in it, and we're going to be dealing with the law of sines, which is the following two formulas, or the law of cosines, which is potentially the other two formulas. So let's look at those in a little bit more detail.